going to put these transformations to some practice now by just trying to graph a function just by knowing its transformations and without actually creating a table of values and calculating every single point. So looking at the function g of x equals x plus 3 squared minus 5, I'm going to pick this apart and look at the minus 5 on the outside first. A number that is added or subtracted after squaring is a vertical shift. So I first identify this as a vertical shift. And then I try to figure out from there which direction it would go, knowing that the vertical shifts always go in the more intuitive direction. A negative number would be down, which is the negative direction. So this is a shift down 5. Now I'm going to look at the plus 3 in parentheses. That's a number that is added directly to the x variable. So I know that that movement should go in the x direction. That is a horizontal shift. And now I want to keep in mind that for my horizontal shifts, the direction is always a little bit counterintuitive in that a number that's added should actually move in the negative direction. So this is going to go left 3. So the way I'm going to draw this graph is to start with my knowledge of what the graph y equals x squared looks like. So the graph of y equals x squared is this parabola that I've dashed in, and it passes through the points 0, 0, 1, 1, 2, 4, and 3, 9, and it has symmetry, so really we only need exact points for one side of the parabola. Then we can use the symmetry to fill in the other side. What I can do to draw my graph is start with this vertex here that's at 0, 0. The vertex is the point where the graph turns around, and shift it first left 3. Oh, it doesn't matter which order we do these transformations in. We'll still get to the same place. But I'm going to go left 3 and then down 5. To get to my new vertex. So this vertex, or this point here, is the turnaround point of my shifted graph. Now, instead of taking every point on the graph, the original graph, and trying to shift it, which requires us to draw the original every single time, it's easier for us to just take this pattern here and draw these points relative to our new vertex. So that I'm plotting these points, instead of going relative to the origin, I'm pretending that that point where I just plotted my vertex, I'm pretending that is the origin, and I'm going to plot these relative to that point. So that means, now let's change colors here. From that, that's my new 0, 0. So this one is done. And from there, I'm going to plot the point 1, 1. So I'm going to go over 1 and up 1. Then from there, I'm going to plot the point 2, 4, meaning starting over again from that point, I'm going to now go over 2 and up 4. So that we're really plotting these points relative to my vertex instead of relative to the origin. So the last point that I'm going to plot is this 3, 9, again starting at my vertex. I'm going to go over 3 and then counting up 9. Since I'm at negative 5, I know that's going to get me to positive 4. So I'll plot a point there too. I'm going to go ahead and start to connect this side now in a parabola. And to fill in the other side, all I need to do is use the symmetry. So again, focusing on my vertex, instead of going right 1, up 1, I could go left 1, up 1 to get another point. Or I can look at each point that's on here and pretend that that vertical line passing through the vertex now is a mirror. Where I have this point here, the red point, 2, 4 relative to my vertex. I can now go negative 2, 4, or I can just see what it would look like to reflect this point across that vertical line passing through my vertex. Up here also, this is the point that was 3, 9 relative to my vertex. I can now bounce it across and get another point on the other side, and then I can connect the points to get the other side of my parabola. So the idea of graphing these by transformations instead of plugging all these different values of x in to find the exact y values is that we really want to continually use this 1, 2, 3, 1, 4, 9 pattern that's on the graph of y equals x squared. The way to remember this is that the x values just go 1, 2, 3, and the y values are the first 3 perfect squares. 1 squared, 2 squared, 3 squared. So these points define the shape. All we have to get used to doing is drawing that shape now relative to a new starting point. Let's now go on to this graph here, h of x equals minus x squared plus 4. We're going to first identify the transformations. We have 2 of them. One of them is this 4 that is added after squaring, and the other is this minus sign in front of the x squared. Remember that minus sign in front of the x squared is technically a reflection about the x-axis, but in the case of a parabola, it just has the effect of making that parabola open down. Okay, so we've got a parabola that opens down, and we've had a second to think about this plus 4. Since that is added after squaring, we know it's a vertical shift. Vertical shifts go in the intuitive direction, so this should be a vertical shift up 4. All right, so the first thing that we want to do is find our new starting point. If our original y equals x squared parabola had its vertex at the origin, after shifting up 4, our parabola will have its vertex up here at 0, 4. Now, because the parabola opens down, I know that when I follow my x, y, 1, 2, 3, 1, 4, 9 pattern, this applies every time we're drawing a graph of a parabola. When I apply this 1, 2, 3, 1, 4, 9 pattern, all I need to do is draw these y values going down instead of up. We're still plotting them relative to our vertex. So we are still starting at the point 0, 4, and from here drawing 1, 1, meaning I go left or right 1, and I go this time down 1 instead of up 1. And then the point 2, 4 relative to there. And then the point 3, 9 relative to that vertex. So we see how quickly we can draw a parabola once we really know what it looks like and what these transformations mean. I'm going to go ahead and reflect each of these points. This time the vertical line passing through the vertex is the y-axis, so it's already kind of drawn in for us. It makes it a little easier to do the reflection. This point here at 2, 0 will get reflected over to negative 2, 0. This point down here at 3, negative 5 will get reflected over to negative 3, negative 5. Now I'll connect the points, and I can see the result is a parabola that opens down that has been shifted up 4 units. So it's all about using these values, which we want to remember. these values define the shape of a parabola. So these define the shape of a parabola y equals x squared. What we're doing with these, what we call rigid transformations, shifts and reflections, these are all transformations that don't change that shape at all. We're just redrawing that same shape somewhere else on our coordinate plane. So we want to remember these numbers so that when we figure out where our new vertex is and what direction our parabola is oriented, we can just use these values and always just start plotting these points relative to our vertex to get the final graph.